Hi, how are you? I'm Ken Andrasco from the Forest Carbon Partnership Facility team here at the World Bank, and I'm here to talk to you today about what is called Component 4 in the RPP template, and that refers to the design of a monitoring system for REDD, often known as MRV, for measurement, reporting, and verification. And the MRV component really integrates all the major aspects of REDD in a country. In Component 1, you're asked to identify the major drivers of deforestation. In Component 3, you will develop a reference scenario of greenhouse gas emissions historically in the past and potentially into the future. And then in Component 4, in the MRV section, is the time to measure the changes in forest cover, greenhouse gas emissions, and the impact of your REDD strategy and compare it back to the reference scenario. So in Component 4 in the template, in the RPP, it talks about two major elements. A, which is designing a monitoring system for MRV of emissions and removals of greenhouse gases. That's the carbon side that you're probably most familiar with. And also there's a B part on other benefits and impacts in relation to the reference scenario. A couple of things you might want to keep in mind in this section are designing your system to consider monitoring rural livelihood changes, the conservation of biodiversity, key governance factors potentially important in REDD implementation, and how the REDD strategy impacts the forest section. So in the first part, the carbon side, emissions and removals, a couple of points to consider are what will be the monitoring system, what will be designed for to address deforestation, also degradation or not, what kinds of lands, how will the emissions reductions be measured and monitored, and what are your existing capacities so far and your future capacities in terms of implementing such a design. In Part B, in MRV of other benefits and the impacts of REDD programs, so a couple of key questions are how will the monitoring system address governance factors that are important in implementing REDD programs? How might it monitor social and environmental impacts? Does it provide for establishing independent monitoring and review and some role for local stakeholders and civil society? And addressing what the role might be for NGOs, for indigenous peoples, institutes, government agencies, the private sector, etc. Why is it important to have a high-quality MRV system? Basically, the MRV system is the means of comparing the changes in the land use sector from your REDD strategy and programs to the reference scenario, and that's how REDD benefits are measured. Secondly, it gives you the opportunity to evaluate your REDD program effectiveness. Thirdly, it might an improved, enhanced, high-quality MRV system is more likely to allow a country to compete in global carbon markets and may allow a country to avoid discounts in carbon prices, which could occur over time. The design of the MRV system is a means of integrating a number of tools and requirements. The main elements are the system technical core, which include the forest inventory, classic forest inventory on the ground and that you may be familiar with, and then remote sensing by satellites or photographs for forest area change, and then geospatial mapping of data in GIS systems or otherwise. A key tool is the IPCC Good Practice Guidance Methods that you probably are familiar with. The system needs to both represent the reference scenario and how it changes over time, so you're comparing to that. Key decision needs to be made is will the system include monitoring degradation of forest in forest management practices or through cultivation practices. Some decision support tools might need to be developed to help policymakers make decisions about MRV system elements, and national institutions probably need to be addressed to help address some governance issues, including transparency and so forth. There are many sources of data of different kinds of remote sensing data that might be available. Here's a classic table that lists coarse, medium, and fine resolution remote sensing sensors like SPOT and Landsat, etc., which are quite common, gives their the area that they're able to see, to resolve, some rough idea of cost, and some idea of how they might be used in monitoring. And the GOFC Gold document referenced in the back includes more of this kind of material. Some key decisions include whether or not to address forest degradation. That offers some specific technical challenges, may require documenting forest disturbance history in the past for comparison, may be difficult for classic optical remote sensing techniques like Landsat, satellite imagery to look through dense clouds in tropical forest areas. It's likely to require a very site-specific calibration of remote sensing with ground-based forest inventory data. And so there are significant cost implications and trade-offs with the carbon benefits that might be accrued. So it might be possible to do a quick assessment of whether or not it makes sense to address degradation or not. You can see in this slide that in the bottom right-hand corner, the Landsat image shows a little white square where it's possible to see that some forest area has changed. In the next slide above, called ICONOS 4 meter, it's possible to see that area in quite a bit more definition, but you still could not really tell if forest is degrading or not. And then in the upper left-hand corner at the 1 meter resolution, it's possible to see individual trees in the forest canopy. So the implication is that finer resolution data done annually at a significant cost might be necessary to address forest degradation, but these methods are evolving.